Hello, everyone. So we have now another geometry problem. This is a grade 11 problem. So what we have is AB is the diameter with 8 units, and C and D are on the semicircle with CD and BC is 2. And what we want is AD. I'm going to name this as X. So like what I'm going to try first is using the law of cosine, but for us kind of see that we can use law of cosine in this problem is just we need to have some like size and angles, but there is no angles right given, right? But there is a hint in this problem, like which is like CD and BC are equal. So why this is important? Because if you have two chords, let's say in this case, CD and BC are equal, their intercepted arcs has to be same as well. So arc DC and arc BC should be same, which tells me if I connect the A to C, the angle in between the chords are going to be equal to as well. Because since we know arc DC, I will say DC, is congruent to BC, CB as the arc measure, then their inscribed angles like this one and the inscribed angle, this one has to be equal to each other. So, but in this case, we can still now use the law of cosine, but in order for us to use law of cosine, just let's remember the law of cosine in the first place. It's basically you square one side, and that is equal to sum of the squares of the other two sides, and subtract the product of those two sides, like in this case B and C, and multiply by cosine value of the angle that is opposite to this side that is alone, which I'm gonna name this is cosine A. And this is law of cosine. If you don't know how to drive, make sure you kind of take a look at that as well. And that's the law of cosine. But to use this one, we need at least two sides and one angle, or three sides to get the angle. So we have two sides and this angle, but we don't know the measure. But maybe we can try finding the AC. So when you have a triangle facing like that is actually on the diameter, which is AB is the side as a diameter, the angle on the semicircle on the circle is actually 90 degrees. And there's a couple of reasons to make that reasoning why this is 90, but I will leave that for you as a challenge if you don't know that as well. And even this has a name. So this is 90 degrees. So now we can use the Pythagorean to get AC. So 64 minus 4, which is 60. So that side will be square root of 60, which is just 2 root 15. If I feel that it's going to be better to use. And now we can use the law of cosine by using this angle. I'm going to name this as alpha. The 2 square, which is this side, is equal to square of the root 60, which is just 60, plus the square of 8, which is 64, minus 2 times square root of 60, which is 2 root 15, times 8, times cosine alpha. But it doesn't give me actually the angle unless I use a calculator, but we cannot use it. Actually, we can, but we don't really need that, to be honest. And what we want is the cosine alpha, which is going to be useful in the next one, because if I use the log cosine in the other triangle, and only thing that I don't know the angle, the cosine value of this angle, because these two were identical, so we can get what we want. So let's find the cosine alpha in this equation alone. So we have like 4, I can maybe divide everything by 4. So if I divide this by 4, that's 1, and that is 15, and that is 16. And the product is going to be, if you divide this product by 4, so I can cancel this by 4, that will be 2 times 2 times 2, which is going to be 8 root 15 times cosine alpha. If you are confused with this, you can just go ahead and simplify on your own in a different way. But I just divide everything by 4. That is just going to be 8 root 15. Okay, so I can pull this on the other side to make that positive. So then cosine alpha now is equal to, that's 31 minus 1 is 30, divided by 8 root 15. So this A can be simplified. That's 15 over like 4. And 15 I can write as root 15 and root 15. So one of those root 15 will cancel. So you get root 15 over 4 root 15. I mean 4 times 15, right? Yeah, I think you know, just for actually, because I cancel the root 15, so denominator will have now only 4. So again, if you use a calculator, you can get this in decimal, which is not really useful that much, but I'm going to use this cosine as a exact number. So now you're going to use the law of cosine in the ACD. So maybe I can use the 2 squared again because the angle alpha has the cosine value is given. So that's equal to x squared plus the square of AC, which is 60, minus 2 times x times this side, which is 2 root 15. I like to write that way, times cosine alpha. And I do know that's cosine alpha already. So let's plug these. So that should be x squared plus 60 minus, that is 4x times root 15. And the cosine alpha is root 15 over 4. And this 4 and this 4 will cancel. You got 15 when you multiply these two. So you will get x squared minus 15x. And then you got 4 subtract from both sides. So you got 56 is equal to 0. And if I try factoring, I think I can. So that looks like -7 and -8. So x minus 7 and x minus 8 is equal to 0. So the x should be 7 or 8. So we have the either option on the choice, right? But be careful because AB was the diameter, which we were given that's 8. So the AD should be smaller than that. So we cannot really accept this in the first place. So that should be our final answer. So this is one way we can do this problem. And the second way I'm going to use using the Ptolemy's theorem. So if you never heard that, it's good to know as well, especially it's useful for the AME prep. I'm going to kind of remind them just to get started. So whenever you have a quadrilateral in a circle, and then we call that cyclic quadrilateral. So let's say this is the one I have. And if you want to have the diagonals as well, the Ptolemy's theorem is basically says when you multiply opposite sides, so in this case A and B, and add it to the other two opposite sides as like their products to be added to this one, and this is equal to the product of diagonals. So if I name this is like E and this is F, so that will be E times F basically. And this is just the reminder. So if I want to name AB as E and CD as F, so the product of the diagonal is equal to sum of the product of the opposite chords in a cyclic quadrilateral basically. So why this is important? Because we know that this is 2, this is 2, and this is what we want, and this is A. But we don't know the diagonals. Maybe we should connect those. And also we need to have this as well. In our first solution, in one part, I said whenever you have a angle that is facing towards the diameter, that needs to be 90 degrees. So this is 90 degrees. And the same reasoning, this guy is also 90 degrees. So if I use the Pythagorean in ABC, so the AC has to be 64 minus 4, which is 60. So that's root 60. Or you can just leave it as 2 root 15. And we already had this one. And then if I use the Pythagorean in this triangle, which we don't know BD, but I'm going to use x squared plus BD squared is equal to 64. So the BD is equal to 64 minus x squared, because I like to keep only one variable if possible. And this is what we have. So let's apply now the Ptolemy's theorem, right? So the opposite segments, like if I want to take 2 is the one chord, and I can take 8 as another chord, because if you were connecting completely this whole circle, then this guy will be a chord and CD will be opposite chord. So that will be 2 times 8 plus, then you are going to add this, multiply by this. So 2 times x, and this is equal to product of the diagonals. So AC, we already know that's 2 root 15. And then BD, that's the square root of 64 minus x squared. And I see that I can divide both sides by 2 to make it a bit nicer. So that will be x plus 8 on the left side, and then the right side will be root 15 times 64 minus x squared on the radical. And it's not nicer to deal with the radical. I can square both sides. So if I square the x plus 8, I will get x squared plus 16x and plus 64. And if you square, the radical will be gone. So you will get 15 times 64 minus 15 times x squared. If I pull this everything one side, so you will get 16x squared plus 16x. And then you got 15, 64. There is 164. If I subtract 15 from 1, you get a minus 1464. You can just multiply if you want to. And I see that I can divide by 16 to make it a bit nicer. So that will give us x squared plus x. And that will give us this 4 times 20, like 4 times like 14, which is 56. And that is my product. So now I can factor again. So that looks like x plus 8 and x minus 7. And then negative 8 cannot be solution for a side. So x should be the 7, which is the same as before. So I hope you got the either approaches. So if you didn't really know how to get the Ptolemy's theorem or Law of Cosine, and even knowing the angle that is on the circumference that facing towards the diameter is 90, if you don't really know those reasoning, I highly recommend you take a look at those. I'll just attach some additional resource in the description so you can take a look at. But these are some important concept that needs to be, I guess, digested. So that is what we have for this problem. I hope that was clear. I'll see you in the next video.